Vorapattanapaibul. Please welcome. Hello คุณนัทสวัสดีค่ะคุณนัท how are you today?
Yeah, today I'm a little nervous and very interesting.
All right, so what do you have today to present to the judges?
Okay, today my name is Nutt Vorapattanapaibul. I'm a master student, and today I would like to present about the alloy that are using in the orthodontics. Yeah, the orthodontics.
Are you ready?
Yes.
Take a deep breath and off you go.
Okay. So, everyone want to have a nice looking, don't you? We're familiar with the orthodontics, as it helps many people to have a confident smile, including me. But do you know that it is discomfort to have the orthodontic wires and brackets inside your mouth? Furthermore, we get a lot of pain when meeting the doctor because doctor, they just adjust the wire to move our teeth. In addition, the side effect of this pain is that our teeth will not move physiologically. Since the root is moved too fast and it will be damaged, it's meaning that we will lose our teeth easier when we get older. The conventional orthodontic wire is made from stainless steel, but the limitation is that it cannot hold the force for a long time. This stainless steel has a lot of disadvantage. As you know that it cannot spring back, can hold the force. Yeah. And the next thing is, in order to move the teeth further, doctor needs to apply more force. This excessive force is the main reason that causes the pain, and it makes the teeth move not physiologically. To move the teeth further and require less force and constant. This why may be the answer. This why is the nickel titanium, the shape memory alloy. This unique alloy can absorb and hold the force longer than stainless steel, and it doesn't losing the original shape. As you can see that after I unload it, it turned back to the original shape like this. This property is called superelasticity, and it can move the teeth further than using the stainless steel, more than 10 times. And nowadays, nickel titanium is widely used in many modern orthodontic clinics, which help patients to get less pain, whereas the teeth could be moved further. Next time, when you go to the doctor, when you meet the doctor, do not forget to ask them, "Doctor, do you use nickel titanium?" Thank you.
Thank you very much. So I think everyone, not everyone, but many of us here may have experienced some braces before, and I did too. So what do you think? Over to you, judges.
Well, you talk about the shape memory alloy.
Yes.
Right? The question that I have in mind is, what is the functionality of why it's shape memory?
Why shape memory?
What kind of function that make it that way?
So the shape memory, as you can see that this one is the shape memory. It can memory itself, the shape itself. So if we bend it to the arch Y, like we put in our mouth, and then we put in the patient mouth, it will follow by the shape of the patient mouth, and then it will trying to go to returning back to its original shape.
My question is about what kind of scientific story behind that.
Is this material is the material science. We control the property of this material by control the chemical composition. This one is made from nickel and titanium, and the property depends on the chemical composition.
How it's different from stainless steel?
Yes, the stainless steel, as you can see, that it can hold the force, it can keep the force for itself, but not for a long time. So as we research, the stainless steel can release the force to move the teeth for not more than 1 week.
I think his question was about the chemistry. For example, how the two atoms, they can absorb energy and maybe can release some, and what the scientific basis of your talk, chemical bonding or electron transfer, whatsoever is about the science.
Do you know about the? Do
We
you
don't
want
know.
to know about the?
We would like to
mechanism?
know. Yeah, we would like to know.
About the mechanism of this, right? So this material has two crystal structure. One at the we divided two crystal structure by the temperature. We call this the active temperature, which can divide it to crystal structure. So if one structure, the low temp structure, receives the force, the atom will expanding, right? When the atom receives the force, it will expanding. But then when we heating up, this atom will try to rearrange itself, which means it's going into another structure. And from the expand, it will shorten by twin itself. And this is the cycle. So when it receives the force or stress, it will expand. And after that, if it receives the heat or the temperature is high, it's going up, the structure will twin itself, shorten. It works something like that.
Well, I think it's very nice. You have put things in a very nice order in your presentation, and your presentation is very clear. But I think what we try to encourage is that if you could elaborate, what does it mean by alloy? Because you start with the word alloy, right? And from that word, if you can explain what alloy is and what's the difference between the two kind of materials, using some, I don't know, some kind of demonstration or pictures or some props, to show that just the difference of the chemical structure of the two things, and why these two chemical structure affect, the property, the physical structure of this, it would be perfect. I think it's very relevant, and very useful, but if you could talk a little bit more about that part. Yeah, thank you. Yeah.
Thank you.
I just have a very quick question. Did you get the braces for this competition? Is that part of the props?
No, this is the real one. This is the real one.
Okay.
Thank you very much.
you.
Thank you. That